Golf is among the most frequently played sports in the United States and has been soaring in popularity since the COVID-19 pandemic. With this surge in popularity comes millions of new players wishing to hit a ball 300 yards with their driver or precisely interpret the contours of a putting green. Putting typically makes up roughly 40% of a golfer's total strokes per 18-hole round and is where an average player loses almost 4 strokes against the field. For this reason, it is widely considered the most aggravating aspect of golf and the area where golfers have the most difficulty seeing improvement. Today, practice putting greens, whether at a golf course, driving range, or in-home, offer only fixed terrains for golfers to practice on. This restricts golfers to limited putting movements, making it more difficult to analyze the contours of new greens. Unlike other skills in golf, putting can only be improved through repetition and by reading and putting on different green terrain styles. Golfers need a versatile practice green that can replicate any putt that a player may encounter. The team at Putt Better has created a solution, an automated, dynamic terrain putting green that can adjust its contours to simulate various real-world course conditions, mimic the look and feel of playing on an actual putting green, support a golfer's weight, and consist of modular pieces. The heart of the system lies beneath the surface. A network of actuators is positioned under a flexible but sturdy rubber mat and high-performance putting turf. Each actuator is driven by an individual motor. This motor connects to a lead screw via a timing belt, creating a pulley system as the motor begins to turn. As the lead screw rotates, a box channel, which connects the lead screw to a threaded rod and acts as a carriage, will raise or lower along the lead screw depending on the direction it is turning. The threaded rods are fitted with circular aluminum caps with a contoured upper surface that will push into the rubber mat to achieve slope. Thus, each actuator individually adjusts in real time to create hills, dips, and slopes, up to a 3-inch total difference in elevation with high levels of precision. The actuator caps, which are 13.4 inches in diameter, are positioned such that they touch each other, reducing gaps and ensuring smooth transitions between terrain configurations without abrupt changes that might disrupt gameplay. Engineering analysis and initial testing have proven this network of actuators to support weight and achieve PGA-certified contours. Since there will be gaps between actuators as the caps are circular in shape, the material and thickness of the mat chosen was paramount to reduce deformation in these critical areas. Engineering analysis proved that neoprene, a type of rubber that is strong but ductile in nature, could readily bend to achieve contours but still support weight. In all cases, including a user stepping only on a gap, neoprene produced deformations of 1 inch or less, and was found to be most viable at 0.7-inch thickness. Its thickness and sturdy material properties also ensure it sufficiently mimics the feel of standing on actual grass. Above the rubber mat lies a high-end turf mat made of polypropylene, an industry-standard choice for artificial putting greens. Each golfer or driving range's needs are different, whether it be in the amount of money they are willing to spend on the product or the available space they have to house it. Thus, the Putt Better is a modular device. Customers can choose to buy any number of individual putting green modules they desire, whether it be just 1, 3, or even 10. The modules simply need to be slid into place, and a robust communication and wiring system will assure high-end performance and precise contours, regardless of the size of the green created. Its hexagonal shape allows for the greatest packing efficiency of actuators, ultimately reducing the number of gaps. Its modularity also improves the ease of manufacturing, as replicable processes can be employed rather than custom making each one to lower costs for customers. Users can connect up to 40 modules together in any configuration. With a robust and dynamic communication protocol, the green layout is handled automatically upon startup. There is no need for the user to input the amount or map of green modules. The current technology in the design uses low-powered microcontrollers and efficient motor drivers to control the system at a minimized power usage rate for users. This technology selection is crucial in the product's ability to connect up to 40 modules together. To date, the team at Putt Better has created 3 individual prototypes to prove the design's feasibility. The first, a communication prototype, consists of a series of interconnected Arduinos that will light up when addressed by a main controller, proving that the modules can communicate with one another, regardless of their amount and configuration. Each Arduino will represent one module, and a light flashing will represent the module receiving contour adjusting information. The second prototype is an individual actuator, closely mirroring those contained in the actual system. It lowers and raises via a stepper motor and pulley system, and its cap, despite being made of wood, is cut identically to the shape of the actual aluminum caps. Although supporting weight is an objective that hinges on the cap being manufactured with aluminum, weight will still be placed on the actuator to prove the engineering analysis was correct. The third prototype will prove that the rubber mat and turf will not experience excessive deformation when stepped on, and that the surface quality mimics an actual putting green. 7 wooden caps, shaped identically to their aluminum counterparts, will be placed beneath the mat and turf, arranged in a hexagonal formation. A series of wood blocks attached to one another and the cap by Velcro, and creating a maximum elevation change of 3 inches, can be inserted or removed to simulate contour changes. This prototype aims to illustrate to users how it would feel to stand on the putt better. Future work for this project includes further prototyping, developing an intuitive user interface to input contour preferences, and designing holes for the golf ball to roll into. While still in its early stages, significant progress has been made to solve one of the largest problems faced by golfers by creating an automated dynamic terrain putting green. We hope you enjoyed this video, and we hope you consider how the putt better can help you putt better.